Good morning, students. I hope that you have watched last 3 lectures on number system. This is the 4th lecture in which we are going to learn about divisibility test on numbers up to 17. All right, without any further ado, let's start. Let's start with divisibility by 2 to the power n. It is very clear that if you put the value of n to be 1, you get 2. For the value of n to be 2, you get 4. 3 you get 8 and 4 you get 16, right? Say 2 to the power 4 is 16. Anyway, so what we are going to do is check the last one digit if we wish to check the divisibility by 2. Check the last 2 digit if we wish to check the divisibility by 4. Similarly, last 3 digit and last 4 digit. Well, let's try this over here. Let me write 2, 4, 8 and 16. Now, if we check the last one digit, we say that is 2 and 2 is divisible by 2, so the entire number would be divisible by 2. If we wish to check the divisibility by 4, we'll take the last 2 digit. As we can see, last 2 digit is not divisible by 4, so we'll say the entire number to not be divisible by 4. Take the last 3 digit, that would be 72 and 62, no, won't be divisible by 8, so the entire number won't be divisible by 8. We take last 4 digit divided by 16, we get 64 and 38, 32, 62, no, not divisible by 16 as well. So this is how we divide, at least we check the divisibility by 2 to the power n. Let's do that once again. Last one digit, yes, divisible by 2. Last 2 digit, yes, divisible by 4. Last 3 digit, no, not divisible by 8. Last 4 digit, 15, no, not divisible by 16. So that was all about divisibility by 2 to the power n. All right, let's check one more. I mean, since we haven't got any number divisible by 8, let's check this one. Last 3 digit, 8 and 56, yes, this is divisible by 8. Last 4 digit, no, not divisible by 16. This one might be, let's check. 16, 144, that would be 15. All right, divisible by 16. So I guess we got an idea that how to check if the number is divisible by 2 to the power n. All right, now divisibility by 3 to the power n. If you put the value n equals to 1, you get 3, and for n equals to 2, you get 9. How do we do that? What we do is, there are two different methods. We'll learn about both. Let me put some space actually. What we do is we add all the terms. We add all the terms. That is 4 plus 7 plus 2 plus 8 plus 6 plus 3, which is 9, 18 and 12, that is 30. If the said number is divisible by 3, then the entire number would be divisible by 3. And same goes for 9 as well. If the sum is divisible by 9, the entire number would be divisible by 9, but as we can see, 30 is not divisible by 9. So we say not divisible by 9. But there is an easy method out. What we do is, well, I like the second method better. What we do is we write 472863. and we start cancelling out the multiples of 3. All right, instead of adding and then dividing by 3, what we do is we add and divide as we go. 3 is divisible by 3, 6 is divisible by 3 as well. If we take 4 and 2, that is 6 and divisible by 3, 8 and 7, that is 15, divisible by 3. So the entire number would be divisible by 3. Let's check the same with 9. We anyway know that it won't be divisible by 9 because we have actually checked it. But anyway, let's do that. Alright. So if we take 7 and 2, that would be 9, cancelled. 6 and 3, that would be 9, cancelled. 8 and 4, that gives 12, won't be cancelled. So this again is not divisible by, let me write, not divisible by 9, but yes, divisible by 3. I guess we got a basic idea. Let us solve one more so as to get a clear grasp. Let us directly divide it by 9. So if we take 4, 3 and 2, we get 9 gets cancelled. 8 plus 8 is 16. 16 plus 5 is 21. That would be 6 and 9. Okay, this ain't divisible by 9. Why? Because 4, 3 and 2 makes 9. That gets cancelled. 8 2s are 16 plus 5, 21. 21 is not a multiple of 9. Won't get cancelled. So again, this is not divisible by 9. Maybe divisible by 3, but not divisible by 9. Divisibility by 5 to the power n. All right. So what we'll do is, let me write, at least let me bring these closer. This would be exactly similar as 2 to the power n. For n to be 1, the value was 5. If 2, 5 to the power 2 would be 25, and for 3, 5 to the power 3 would be 125. We are going to check the last 1 digit, last 2 digit, and last 3 digit. All right. So I'll write over here, say 5, 25, and 125. Let's see. Last 1 digit is divisible by 5, so this would be divisible by 5. Last 2 digit is divisible by 25. It would be divisible by 25. Last 3 digit. Last 3 digit. Is that divisible? No. That is not divisible by 125. So we'd say the entire number is not divisible by 125. One more. Last 1 digit is divisible by 5. Last 2 digit as well is divisible by 25. Last 3 digit, I'd say, is not divisible by 300. Okay. 250, no, is not divisible by 125. So the entire number won't be divisible by 125. All right. Next, divisibility by 6 and 12. So in order to test divisibility by 6 and 12, what we do is, first of all, prime factorize this to get 2 times 3, and prime factorize this to get 4 times 3. Now we'll have to apply two different divisibility in order to check if it is divisible by 6 or not. Let's start with 2. Let's check for the divisibility of 6 and 12 over here. Let's start with the first digit. We are going to check if it is divisible by 2 or not. Yes, 8 is divisible by 2. So the first number is divisible by 2. Let's check for 3. How do we do that? We have learned we start cancelling. 6 and 3 anyway get cancelled. 4 and 5 gives 9, cancelled. 7 and 8 is 15, gets cancelled. So this as well is divisible by 3. So the entire number would be divisible by 6. Let's try that again. Let me write that. Can't erase it. 5, 6, 7, 8. All right. Let's try this for 12. Is last two digit divisible by 4? Well, I guess not. So it won't be divisible by 4. All right. I mean 12, sorry. Since 12 comes from 4 times 3, and since last two digit is not divisible by 4, we'll say the entire number not to be divisible by 12. Let's check this one. Let's check just for 12. If something is divisible by 12, it obviously would be divisible by 6 as well. So we are going to check for the divisibility of 4. 92, last two digit, is divisible by 4. So that's a good sign. Let's check for 3, divisibility by 3. If we add these, 9 gets cancelled, 6 and 9 anyway gets cancelled, 7 and 2 is 9 gets cancelled. So 12 is divisible by, the number is divisible by 12 very clearly. Alright, let's move on to the divisibility by 7, 13 and 17. A little bit tricky, won't say difficult, a little bit tricky. All right, so what we do over here is we use -2 for this one, +4 and -5. These are called modifiers. We'll understand the usage. All right, now what we do is we remove the last digit, unit digit. We write the number without the unit digit and we multiply the unit digit by the modifier. That is subtraction of 16, that would be 329. Now what we do is we again remove the last digit and we write 32 plus 9 and we multiply it by the modifier again, that is subtraction of 18, which gives you 14. So now we can see, we can continue again, but we can very clearly see that 14 is a multiple of 7. 14 is divisible by 7. 14 is divisible by 7. So we'll say the entire number to be divisible by 7. Very simple was that. You need to learn the modifier at least. All right. For 13, it is +4. We are going to do the exact same thing. We are going to write the number without the unit digit. We'll write plus unit digit times. The modifier was +4 this time. That gives us 20. That is 429. We'll do that again. 42 plus 9. And the modifier again would be 4. That is 36. If we add that, that would be 78. Now, since we were checking divisibility of 13 and we can very clearly see that 78 is a multiple of 13. So we'll say this to be divisible by 13. All right. Let's go for this one. Let's try to check the divisibility of 5270 by 17. And we can see that the modifier for 17 is -5. We are going to do the exact same thing which we did in the earlier stages. We'll take the entire number, removing the unit digit. We'll add the unit digit and multiply it by the modifier. That would be 527. Modifier was -5 anyway, but that won't make any difference. We'll carry on with 5 to 7. 5 2 will take 7, the unit digit separately, and multiply it by modifier. 52 minus 35 would give us 17, which is divisible by, anyway, divisible by 17. So we'll say this entire thing to be divisible by 17. Very simple was that. Although it may look that it is a very large process, it would really be helpful if you wish to do that orally. Okay, you don't need to calculate all this on your notebook. All right. Now, for those who felt that the method which I just gave you for divisibility of 7, 13 and 17 is lengthy, we are going to learn a new method over here. All right. Now, it depends which one you find difficult and easy. That's a personal choice, but my duty is to make you understand these methods. In this method, we are going to use last 3 digits. So we take last 3 digit and we again take last 3 digit. I mean the next 3 digit. If over here there are only 5, we take the last 3 digit and then we take the remaining 2 digit. Okay. Similar goes for this one. We take the last, since there is 6 digit, we'll take the last 3 digit pair and the remaining digits. So we make the pair of last 3 digit and then we take the remaining portion. Now we have to check which one is greater, 817 or 432. Obviously 817 is greater than 432. We subtract them, we get 5, 8 and 3. Now we'll have to check if it is divisible by 385 is divisible by 7 or not. Well, I can clearly see 35 and 35, it is divisible by 7. Let me write it like this. It is divisible by 7. So the entire thing would be divisible by 7. Although the method which I gave you earlier is good for shorter, smaller number, this one would be helpful if the number is around 5 digit or 6 digit. All right. Over here we'll check divisibility by, let's say, 11. What we do is we write 803 minus, 80, my bad. The pair is of 80. So obviously 366 is greater. We'll subtract 80 from 366. We get, my bad, not 3, 286. All right. Now, as we can very clearly see that 286 is divisible by 11. So we'll say the entire number to be divisible by 11. Let's check for 13 if the next number is divisible by 13 or not. Again, we took the last 3 digits and the remaining portion. We'll subtract the larger number by the smaller one. We get 91, right? 91 is divisible by 13. So we'll say this entire number is divisible by 13. Now, let's try to solve some problems very quickly. We have learned almost all the method. Okay, one method is still not there. Divisibility by 11. My bad. Let's learn divisibility by 11. Although this method works for larger number, there is an easy method for divisibility by 11. Let me write the same number, 80366. What we write is 80366. What we do is we take the sum of digits at even places and sum of digits at odd places, and we find the difference. Let me remove this from over here. We find the difference of these two. If the difference is 0 or multiple of 11, we say that the number is divisible by 11. So let us do that. We'll add 8, 3 and 6 together. We get 9 and 17. We add the remaining numbers, that is 0 and 6. We get 6. We find the difference, that is 11. And since 11 is a multiple of 11, we'll say the entire number to be divisible by 11. All right. Let's try to solve some problems. I'd say pause the video, go through all the methods, all the divisibility tests which we learned, and then come back to these questions. Which of the following number is divisible by 4? We'll check the last two digit. 82 is not divisible by 4. Won't work. 36 is divisible by 4. That is our answer. Next question. Which one of the following option is divisible by 3? What we'll do is we'll start cancelling out. 3 gets cancelled, 6 gets cancelled, 7 and 2, 9 gets cancelled, 3 gets cancelled, but 5 and 3 gives 8, which does not get cancelled, is not divisible by 3. 6 and 3 gets cancelled, 9 gets cancelled, 5 and 4, 9 gets cancelled, 8 and 2 would give 10, is not a multiple of 3. 3 gets cancelled, 9 gets cancelled, 4, 3, 7 to 9 gets cancelled, 7 and 5 is 11, which gets cancelled, so C would be a right option. Okay, so we are not going to do basic questions over in here. We actually learned the divisibility. We are going to do some advanced stuff over here. So the question states 1, 2, 3, 4, 5, 6, x and y is divisible by 8. Whenever we are set divisible by 8, we check for the last 3 digit, which is 6x and y. 6xy. Now we'll have to think which of these would be, what should be the value for x and y for it to be completely divisible by 8. I can very clearly see that if I put the value 0, 0, that is 600. 600 is divisible by 8. So if I put the value 0, 0 in place of xy, that would work. So would 0, 8. So would 1, 6. We keep on adding 8. That is how we get all the multiples in order. So it would go till 96, I'd say. Right, 696. Let me write that. It started from 600 and it went all the way to 696. It is asking for total number of pairs. As we can see, 1, 2, 3 and so on, it would go till 96. How many pairs are there? So this is 8 times 1 and this is 8 times 12. So there are 12 pair over in here and 113. So our final answer would be option B. Alright, let's try to solve this one. Let me write the question. The question states that this should be divisible by 3 but not by 9. Now, first of all, we'll try to use the divisibility test for 3. 3 and 6 gets cancelled. 8 and 2 gives us 10. Divide 8 and 2, that is 10 by 3, we get remainder 1. So we are left with 1 plus a plus b. Now, we are supposed to find the maximum value for a and b, so that the number becomes greatest. Now, the maximum value for a could be 9 and b as well could be 9 because they are digits, which gives us 19. So the value of a and b should be less than 19 because anyway 19 is not divisible by 3. All right. So value less than 19 would be say 18, 15, 12. These are divisible by 9. All right. 3. But the only problem using 18 is that it would be divisible by 9 as well, and the question clearly states that it should be divisible by 3 but not by 9. So we cannot take 18 as our answer. We'll have to take 15, although we can take 12, but that would be lesser one. We are supposed to find the greatest of these. So we'll say 1 plus a plus b equals to 15. A plus b would be 14. And now try and understand, if you wish to make this number greatest, you will have to take the value of a. You will have to take the value of a to be greater. Maximum value of a you wish to take. So maximum value for a would be 9. If the value for a is 9, b would get to be 5. So our number becomes 2, 3. The value for a is 9, 6, 8. Value for b is 5, which is option 6, 8, 5 is option B. Are we good? All right. Class has been going for a long time. This is the last question. All right. We are going to solve. Question gives 4, 8, 5, 6, 3, 2, 7 is divisible by 9. Okay, x, y as well is there. Is divisible by 9, and it as well states x minus y equals to 6. We are supposed to find the value for so and so. The divisibility of 9 works that we do the same as in 3 but use a multiple of 9. 6 and 3 gets cancelled, that is 9. 7 into 9 gets cancelled. This is 12. If we get the remainder from 12, we get 3. So that is going to be 3 left. 3 plus 5 is 8. 8 plus x plus y. Now, 8 plus x plus y needs to be divisible by 9. So the sum could be 9, 18, 27, 36, whatever. Well, we can very clearly see that the maximum value for x could be 9, the maximum value for y could be 9, and if we try to check the maximum value 8 plus x plus y can have is 26. So we would eliminate 27 and 36, all of these. So we are now left with two values. First, if we take x plus y plus 8 to be 9, we get x plus y to be 1. And if we take x plus y plus 8 equals to 18, we get x plus y to be 10. All right, we are as well given the difference that is x minus y to be 6. I'll write x minus y over here to be 6 and x minus y to be here to be 6. All right, we add them, we get 2x equals to 7, we get 2x equals to 16. Over here, the value for x is 3.5, and over here the value of x is 8. Obviously, a digit cannot be 3.5. This one is wrong. We'll get x to be 8. Alright, if x gets to be 8, we'll put the value over here, and if x is 8, y becomes 2 automatically. X 8 and y 2. We are supposed to find the value for root under 4x plus 2y. You put x to be 8 and y to be 2. You get 32 and 4, 36. Root under 36 is 6. So option D is the correct one. Alright, this was all about divisibility factors up to 70. Now, questions are vast. This was the very basic concept which we learned. A few questions because the class became lengthy. I wish you liked the video. If you like the video, please like it and comment any suggestion which you have. Thank you. Have a nice day.